This is part 3 of 6th semester nuclear and particle physics question paper of 2022 Dibrugarh University. So we have already solved up to question number 4. Today we're gonna solve we're gonna answer the question number 5. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT 123. This is my Insta ID. You can follow me on Insta. So now let's start. Now let me answer to question number 5a. Describe the conservation laws of laws followed by the nuclear reaction. Let me write the answer. This is answer to question number 5a. Okay, this is first law. This energy conservation law that is followed by the nuclear reaction, and then next is the conservation of linear momentum. Okay, take the screenshot or you can pause the video or note it now. Okay, then next one is the conservation of charge. Okay, take the screenshot. Then next one is conservation of virial number. Then next, conservation of lepton number. Okay, then take the screenshot. Then this is answer to question number 5b. Let me go back to the question. Okay, here question number 5b, discuss the compound nucleus theory. So here is the answer. Sorry, let me show you again question number 5a. The question number 5a starts from here. This is page 1, this is page 2, this is 3. Okay, this is 4, this is 5. Okay, so this is question number 5b answer. This is page number 1. Okay, this is the second page and this is the third page. Okay, so first write this, then write this one. Okay, next one is this is the fourth page. Okay, after fourth page, and this is the fifth, and this is the last one, sixth page. Okay, so now question number 5c. So here is the question number 5c. This is question number 5c. So how to solve this? So here you see, first let me add the mass of these two reactants first. Okay, so first let us find mass of this lithium nuclei plus then mass of this neutron. Okay, first let's find their mass, sum of the masses that will be given by so let me write this one here, just wait. So 6.015126 U, then this is equal to just give me a second. Okay, now you see 1.0086654 U. Okay, so here it will be, if you add this two, then you must get I have added this two. Okay, you must get 7.0237990. okay, and then again take the masses of these two. Okay, nuclei equal to 4.00260044 U. Then next, mass of hydrogen nuclei 3 you just said 3.016049 U. Okay, if you add these two, then you should get 7.018653 U. Okay, now let us take the difference of these two. Okay, so difference of these two masses, del M, that's going to be equal to if you see this one is greater than this one, so if you subtract these two, then you should get 0.005136 U. That much you're gonna have. So that's why you see the energy released, the value of Q, that will be given by the value of Q. Just wait, let me clean this. Okay, the value of Q will be given by this del M into 931.48. that much MeV we're gonna have. So if you multiply this to 0.005136 into 931.48, then you're gonna get the answer. Okay. So this is approximately equal to 4.784 MeV, right? So this is the answer. So now let's move on to the next question. First let me clean these things. Okay, so here you see this is 5C, or either you need to solve this question or you have to answer, you need to answer this question, derive a relation for nuclear reaction and nuclear reaction cross section. So let's answer this question. Question number 5C, or suppose we have a slab of some material whose area is A and thickness is dx, right? Suppose this is the slab. Okay, sorry, this is the slab, and it's this area, and the area of this face is suppose A, and the thickness, this thickness is dx, right? Then its volume will be A into dx, right? Therefore volume of the slab is A into dx, right? Let the material contains n atoms per unit volume, right? Let n be the number of atoms per unit volume. That means number of atoms divided by volume. Okay, and total number of nuclei in the slab. Okay, therefore total number of nuclei in the slab, that's going to be equal to, you say, if the volume is this and per unit volume we have n number of atoms, so number of atoms per unit volume, that is n into volume, that's going to give you the total number of nuclei, right? N A dx, right? Then we assume that each nucleus has a cross section of sigma, cross section of its nuclei, or you can say, yes, sorry, its nucleus, sorry, okay. Then you see the aggregate cross section for all the nuclei in the slab, that will be given by let me write here. So this is what we have got. Now if capital N, let me take a next page, let capital N is the number of incident particles in a bombarding beam and dn, let me write here, and dn is the number of particles, number of particles interact with nuclei, okay, in the slab, right? That means the slab is bombarded with a beam of n number of particles, and out of n, dn number of particles interact with the nuclei in the slab. Okay, that's it. Then the number of interacting particles by the number of incident particles, that is dn by n. This is the number of interacting particles divided by total number of incident particles is equal to, that's going to be equal to that aggregate cross section that we have got, divided by targeted area. Right? And here you see. So let's put this to value. Targeted area is the total area, that is A, right? Total area of the surface. Okay, that means this is the slab. Let me draw this way. This is the slab, suppose. Okay, and it is bombarded with n number of particles, and this is the targeted area, and out of that, the aggregate cross section of this slab, that's what we have got, this one. So let's put this one here. Okay, sigma small n capital A dx. Now let's cancel a, then it's gonna give you this. Okay, so therefore from here we're gonna get the cross section, that is sigma. So what we're gonna have, if we simplify this, this should be n. Okay, let me take a new slide. Okay, so from this step, let me copy this last step and let me go to a new slide. Okay, so here you see this, from here what we're gonna get sigma is equal to dn by capital N divided by n dx. That's what we're gonna have. So this is the required expression. Okay, so hope you have understood this. Remaining questions will be solved in the next video. Thank you for watching. See you in the next video. Bye bye.